Hi guys, today's notes are going to be over Chapter 2, Section 1, which is called Classifying Matter. What you need to do while we're taking notes today is fill in this table. We're going to have two examples, two categories of pure substances, two categories of mixtures, and we're going to have examples for each of those. So starting out, we need to know what pure substances are. One thing that we want to think about throughout these notes today are why elements and compounds are classified as pure substances and other things are not. So first, let's write down the definition for a pure substance. A pure substance is matter that always has exactly the same composition. A couple examples here are table salt and table sugar, or just cooking sugar. They're two examples of pure substances. So and each of those can be categorized into elements and compounds. So before we write down these as examples, let's make sure that we know if table salt and sugar should be considered elements or compounds. So don't write them down just yet. We just need to have the definition of pure substance. Let's go ahead and add elements and compounds to our table now. So under pure substances, we have elements and compounds. Okay, so the next key things that we need to know, how do mixtures differ from pure substances? Well, an element is a substance that cannot be broken down into a simpler substance. It is the smallest or the most pure type of substance that you can have. An element has a fixed composition, which means that it's always going to look exactly the same. Every sample of it will be the same. And it contains only one type of atom. This part is what really makes elements different from anything else. All of the atoms in an element are exactly the same. Okay, next, examples of elements. So we have just basically anything that's found on the periodic table. So some examples would be oxygen and nitrogen. Those are in the gas that we breathe. A couple elements that are liquids at room temperature are bromine and mercury. And then we have solids, carbon is an example of a solid that is part of what makes up the lead in your pencil. And then soft drink cans, aluminum cans, are also known as tin cans. They're made from aluminum and also tin. So they're technically mixtures, but they are made of two elements. Okay, so something else that we need to know about elements is that when we write elements in chemical formulas, we use symbols. I'm sure you've learned a lot of these symbols already. For example, C representing carbon, Al representing aluminum, and Au representing gold. What you want to make sure that you do when you're writing these is if it's a single letter for an element, then you're just writing a capital letter. And then when it's two letters, like Al and Au, the second letter has to be lowercase. That's to let people know who are reading the formula how many different elements you have. So you're looking at the different capital letters, and then the lowercase letters are just there because we run out of uppercase letters. Let's see. Next we have symbols are used because we have so many different languages and the words for the elements are different in every language. Let's see. For example, this is the word for nitrogen in French, and then in German, and then in in Spanish. But all scientists use the symbol N for nitrogen. Okay, here's some examples now of elements then. Aluminum, carbon, gold. We also have iodine here. Iodine is something that you may have had put on your skin at the doctor's office to clean or disinfect. Usually turns your skin yellow. Okay, anything on the periodic table can also be an example of an element. Let's go ahead and list some examples of elements now. So I've listed carbon, iodine, gold, iron, copper, oxygen. Anything from the periodic table can be listed here as an example. So now talking about compounds, we're still wanting to make sure that we explain why pure substances are different from mixtures. So a compound is a pure substance. It is made from two or more simpler substances that can be broken down into those simpler substances. What's really important to know about a compound is that it always contains two or more elements that are joined in a fixed proportion. And when I say joined, I mean they're actually chemically bonded, so they're actually fused together. And when it says fixed proportion, that means the same number of each type of element. So when we talk about water molecules, a molecule being something that has two or more atoms that are bonded together. When we talk about water molecules, we call them H2O because there's two hydrogens and one oxygen, and that's the case for every single molecule of water. So it's always a fixed proportion. If we're talking about CO2, carbon dioxide, there's always one carbon and two oxygens. If I'm talking about salt, NaCl, there's always one sodium and one chlorine. So the proportions are always the same. One other thing that we want to know about compounds is that when you combine those elements, when they actually get bonded together, that compound has different physical properties and different chemical properties as well from the substances that they were made from. So when we talk about water, the element hydrogen is used to actually start fires. It's used as a fuel that it actually powers the space rockets. And then we have oxygen, which we know is required to keep a fire burning. You put hydrogen and oxygen together and you get water, which is used to put out fires. So completely different properties from the hydrogen and the oxygen when they're on their own. So here's one more example of a compound. We've got silicon, which is a metalloid, meaning that it has both metal and nonmetal properties, and then oxygen. And when you put them together, you get this crystal, silicon dioxide. Okay, so now let's go ahead and add in our examples of compounds. So I put water, sodium chloride, carbon dioxide, and silicon dioxide. There's others. You might put sugar is an example. It has a lot of different elements in it. So I'm not going to list all of them right here. So that's okay. Next. Okay, I'm sorry. There's some folks at my door. Okay, how do mixtures differ from pure substances? So mixtures are different from pure substances because they can vary. Each batch might be a little bit different of a mixture. The properties in a mixture can vary because the composition is not fixed. So when we talked about water and carbon dioxide, those compositions were fixed. They had to be the same for every single molecule. And in mixtures, it doesn't have to be like that. It's not a 100% always, all the time, the same. Okay, so we're going to list our two types of mixtures. The first type is a heterogeneous mixture. And the important thing about a heterogeneous mixture is that the parts of the mixture are noticeably different. So you can actually pick out the different pieces of it. In a homogeneous mixture, the substances are so evenly distributed that you can't distinguish one from another. So let's go ahead and add heterogeneous and homogeneous mixture to our table. And then a couple of examples. The sand in this example here is a heterogeneous mixture. You can see the different kinds of grains. And then we've got a spoon, a metal alloy. Alloy just means that it's a mixture of metals. What you do is you melt down the two metals, mix them together, and then you can forge them into an actual shape, which is how bronze gets made. It's tin and copper that get melted down and then used for different sources. So the spoon would be an example of a homogeneous mixture, and the heterogeneous mixture would be the sand. So listing a couple of those, the heterogeneous mixture here, we have chunky salsa, jam with seeds in it, sand. For homogeneous mixture, I put metal alloys. Another example of a metal alloy could be aluminum foil, which is a mixture of aluminum and tin. Then we also have vinegar and milk. Okay, let's have a couple review questions then. There's 5. Which of these substances is a compound? Correct answer is B, water. It's hydrogen and oxygen. The others are elements. Which of these groups of letters could be used as a symbol for an element? The correct answer here is B. CM would work because it only has one capital letter and one lowercase letter. 3, which of the following does not apply to a compound? The correct answer is C. We cannot separate a compound through physical methods. You need chemical methods to make that work. The rest of those do apply to compounds. Number 4, how does a compound differ from a mixture? The correct answer is D. A compound is made of 2 or more elements in a fixed proportion. So the difference is that mixtures are not fixed proportions. 5, which of these metals is a heterogeneous mixture? Correct answer there is C, sand. And that's all. Where's the stop button? Oh.